So today we're gonna start the discussing the functions of the periodontal ligament. First of all, we discuss the physical functions. In physical functions, today we will study a very important function which is actually shock absorption. How the pedial fibers actually absorb these shocks. If someone asks you that which part of the tooth actually absorb the shock, okay, so it is actually periodontal ligament. So let's start it. Bismillahirrahmanirrahim. Okay, so two theories has been presented in the to understand the mechanism of tooth support. One is tensional theory, the other is the viscoelastic system theory. In tension theory, what they said, basically it states that the principal fibers of the PDL are the major factor in supporting the tooth and transmitting forces to the bone. So according to the tensional theory, they consider the principal fibers of PDL which play a huge role in supporting the tooth and transmitting these forces. When the force is applied to the crown, okay, when force is actually applied on the crown, so the PDL, so the principal fibers, so the principal fibers first unfold, then they straighten themselves, okay. Then these forces are transmitted to the bone, alveolar bone, by causing the elastic deformation of bony socket, okay. They deform the bony socket elastically. But finally, when the alveolar bone has reached its limit, means it cannot tolerate further load, so the load is transmitted to the basal bone. But some investigators or many investigators says that this theory is insufficient to explain the available experimental evidence, okay. So two theories has been presented to understand the mechanism of shock absorption by the PDL. One is tensional theory and viscoelastic theory. In tensional theory, we have studied about the principal fibers which play a major role in them, okay. According to them, this theory, and the force is applied to the tooth, so when they reach the principal fibers unfold and tighten, then these forces are transmitted to the alveolar bone and cause the elastic deformation of bony socket, and when the bone is reached to its limit, the load is transmitted to the basal bone, okay. Now moving to the viscoelastic system theory. According to them, they state the displacement of tooth is largely controlled by fluid movements. In first theory, there were principal fibers, but here the fluid movements, and they consider fibers have only a secondary role, okay. When force is transmitted to the tooth, actually, so the extracellular fluid passes from the PDL into the marrow spaces of the bone through the foramina in the cilibriform plate, okay. So the fluid will move from the PDL into the marrow spaces of bone through the cilibriform plate. The perforations of the cilibriform plate, they do what? They link the periodontal ligament with the cancellous portion of the alveolar bone, okay. So they are more abundant in the cervical third than in the middle and apical third, okay. So according to this theory, the major role of the are fluid movements, actually they say, and the fluid moves from the PDL into the marrow spaces of the bone through the foramina in the cilibriform plate, and basically they link the PDL with the cancellous portion of the alveolar bone, okay. They are more in cervical third, in middle and apical third. After, when the fluids are depleted, actually tissue fluids are no more, so the fibers absorb but they become slight and then tighten, means they become once loose and then they become again tight. This leads to the blood vessel stenosis, means the blood vessels become narrow. Arterial back pressure causes the ballooning of vessels, okay. So the arterial back pressure increases, due to which the vessels becomes balloony, and passage of the blood unfiltrates into the tissues, so means the passage of the blood becomes unfiltrated into the tissues, okay, thereby replenishing the tissue fluids, and they again replenish the tissue fluids.